Today in class, we already did the warm-up to Unit 3-4 notes of focus on square roots. So let's go right down to number 1 and multiply each expression. Okay, let's take a look at letter A. Letter A, oh, it's dots, which means the two terms in the middle should cancel out. So we're going to end up with radical x times radical x is radical x squared. Radical x times the negative 2 is negative 2 radical x. 2 times, whoops, let's make that an x. 2 times radical x is a positive 2 radical x. Negative 2 times a positive 2 is a negative 4. Oh, the two terms in the middle do cancel out like they're supposed to. Squaring and square root cancel out, so I get x minus 4 is my answer. Oh, wow, that wasn't too bad. Let's move on to letter B. I have two binomials. Oh, it's not dots, so nothing should cancel out. They're exactly the same, so we're going to have to do double distributive property. Radical x times radical x is radical x squared. Plus 4 radical x plus 4 radical x plus 16. Combined like terms. Okay, squaring and square root cancel each other out, so I get x plus 8 radical x plus 16. There's nothing else I can do to that, so there's my answer. All right, those were review. Let's take a look at letter C. Letter C is a little different, and hopefully you can see what's different between C and A and B. In A and B, you had radicals in the binomials. In letter C, the whole binomial is a radical. So I can't do double distributive property because the binomial is under the radical. It looks like the radical in letter C is being multiplied by itself. Oh, it's being multiplied by itself, so actually it's being squared. And what do you know about squaring and square root? You're right, they cancel each other out. So my answer just is x minus 5. So again, when you multiply a radical by itself, it actually undoes the radical. Let's review something before we go on. When we had a radical 6 in the denominator, and we rationalized it, and we multiplied it by a radical 6, we ended up with a radical what? You're right, 36, which actually is plain old 6. So again, what happens is when you multiply a radical by itself, it eliminates the radicals because you're actually squaring it. Because radical 6 times radical 6 is really radical 6 squared, which is plain old 6, which I got the long way by multiplying it by itself. Okay, with that being said, let's take a look at the next page. On this next page, it's asking us to rationalize the denominator in each expression. That is, rewrite each expression so that the fraction has a rational expression in the denominator. All right, if I take a look at letter A's denominator is a radical. It's an entire radical. The binomial is under the radical, but the whole denominator is a radical. So when your whole denominator is a radical, you're going to multiply by itself, which means you're going to rationalize the denominator. So whatever you do to the bottom, you have to do to the top. Well, let's take a look at the denominator. What would I get? Well, a radical times itself really means that radical is being squared. Okay, so let's take a look at the numerator. X minus 9 times radical x minus 9. I really can't multiply them together. I can't do double distributive property because one's a binomial and one is just a radical. So I'm going to write it as x minus 9 times radical x minus 9. All right, in the denominator, squaring and square root cancel each other out, so I get x minus 9. On the top, I still have x minus 9 times radical x minus 9. Oh, I can cancel out the x minus 9s because they're like terms and end up with just plain old square root of x minus 9 as my answer. Okay, let's take a look at letter B. In letter B, I have a radical in the denominator, but it's a binomial and the whole denominator is not a radical. So in this case, I'm going to multiply top and bottom by the conjugate. So I'm going to multiply by radical x minus 3. Okay, So on the top, I'm going to end up with double distributive property and get x radical x minus 3x minus 9 radical x plus 27. On the bottom, I'm going to end up with radical x squared minus 3 radical x plus 3 radical x minus 9. Okay, the two middle terms in the denominator cancel out like they're supposed to, so let's see what I have. In the numerator, doesn't look like I can combine any like terms. I'd like to put this x radical x with that 9 radical x, but there's no way I can combine an x and a 9. So there really isn't anything I can do, so I'm just going to rewrite it. X radical x minus 3x minus 9 radical x plus 27. In the denominator, square and square root cancel each other out, so I get x minus 9. All right, so there's my answer. Now let's take a look at that answer. Is there anything else I can do? Well, the top has 4 terms. Well, the only thing I know that I can do to 4 terms is see if I can group it. So I'm going to try that. If it doesn't work, it doesn't work, and that's my answer. So I can GCF out an x from the first pair and get radical x minus 3. I can GCF out a negative 9 from the second pair and get a radical x minus 3. Hey, grouping's working. And all over x minus 9. All right, so I put the GCFs together, so I'm going to end up with x minus 9 times radical x minus 3, because you remember you bring down one common factor, over x minus 9. Ooh, I can cancel out the x minus 9s, so my final answer is going to be radical x minus 3. All right, that wasn't too bad. The only thing is I had to remember when I have 4 terms, I can check to see if I can group. And I did, and it worked. All right, let's take a look at number 3. Rewrite 1 over radical x minus 5 in an equivalent form with a rational expression in the denominator. All right, that denominator is a binomial, and the whole denominator is not a radical, so I can multiply top and bottom by its conjugate. So I have 1 over radical x minus 5 times radical x plus 5 on the bottom, so radical x plus 5 on the top. Okay, on the top, 1 times radical x plus 5 is radical x plus 5. In the denominator, I have 2 binomials that contain radicals, so I'm going to do double distributive property and get radical x squared plus 5 radical x minus 5 radical x minus 25. All right, the 2 terms in the middle cancel out like they should when I multiply by the conjugate, so let's see what I have. On the top, I have radical x plus 5. On the bottom, square and square root cancel each other out, so I get x minus 25. Can I factor and cancel anything or combine like terms? Nope, nothing I can do. So there's my answer. All right, let's take a look at number 4. Solve the radical equation. Be sure to check for extraneous roots. Extraneous solutions. Extraneous solutions are solutions that don't work, that won't make it true. All right, so here we go. I have 3 over square root of x plus 3. So the whole binomial is under a square root, equals 1. All right, to solve radical equations, I have to isolate the radical. Well, really, that radical is isolated. It's just in the denominator. So what I'm going to do is then square both sides. But remember, when you square a fraction, you square the numerator and you square the denominator. So again, I'm squaring both sides of the equation. Let's see what I have. I end up with 3 over, squaring and square root cancel each other out, x plus 3 equals 1. Oops, let's go back. Hopefully everybody caught my mistake here. 3 squared is not 3. 3 squared is 9. Okay, I have a fraction on the left. I'm going to make a fraction on the right by putting it over 1. I'm going to cross multiply and get x plus 3 equals 9. I'm going to subtract 3 on both sides and end up with x equals 6. Okay, let's check to see if 6 works. So if I put 6 in for x, 6 plus 3 is 9, the square root of 9 is 3, 3 over 3 is 1, and it works. So my answer is x equals 6. All right, let's take a look at number 5. Without solving the radical equation, how could you tell that it has no real solutions? Well, now let's think about this. I need 0 as an answer. And whatever I have under the radical has to be added to 9 to get 0. The only thing that I know that can add to 9 to get 0 is a negative 9. And there's no way that I can take the square root and get a negative answer because the radical sign is already drawn for me. So I can tell right now there's no solution to this equation because there can't be a negative answer for the radical. There's no way I can get a negative 9 by taking the square root of whatever I put in for x. It's just not going to happen. All right, with that being said, let's go to the next page, please. On this next page, I want to take a look at number 5. So we're going to start Unit 3-5 notes just a little earlier. Let's take a look at number 5. We're solving radical equations again, but this is a little bit more difficult. In number 5, I have 2 radicals on the left separated by an addition sign. So the object of the game is to isolate the radical. So the only thing I can think of doing would be to move one of the radicals to the other side. So I'm going to subtract radical x plus 5 on each side. So on the left, I get square root of x minus 3. On the right, I get 4 minus the square root of x plus 5. Well, I isolated at least one of the radicals, so I'm just going to continue on and do what I know to do. Once I isolate the radical, I'm supposed to square both sides of the equation. Okay, so let's do that. On the left, squaring and square root cancel each other out, so I get x minus 3. On the right, I have a binomial. And when a binomial is squared, it means to multiply it by itself. So I'm going to have 4 minus radical x plus 5 times 4 minus radical x plus 5. All right, so I'm going to have to do double distributive property to the right side. Bring down the x minus 3. 4 times 4 is 16. 4 times a negative radical x plus 5 is going to be a negative 4 radical x plus 5. Remember, it's multiply the outside guys, then the inside guys. Negative radical x plus 5 times 4 is a negative 4 radical x plus 5. And a negative radical x plus 5 times a negative radical x plus 5 is a positive radical x plus 5, the whole thing squared because you're multiplying it by itself. All right, bring down the x minus 3. 16 comes down. Oh gosh, these guys are like terms, so I get a negative 8 radical x plus 5. Squaring and square root cancel each other out, so I get plus just plain old x plus 5. All right, bring down the x minus 3. I can combine like terms and put 16 with 5 and get 21 minus 8 radical x plus 5 plus x. All right, I have x's on both sides of the equation, so I need to get them on one side, so I'm going to subtract an x on both sides. Ooh, that cancels out the x's, so I get negative 3 equals 21 minus 8 radical x plus 5. I have a radical, so let's see if I can isolate it. I'll subtract 21 on both sides. End up with a negative 24 equals a negative 8 radical x plus 5. I'm going to divide each side by a negative 8 and end up with a positive 3 equals radical x plus 5. Hey, I isolated the radical, so I can now solve by squaring both sides and get 9 equals x plus 5, because squaring and square root cancel each other out. Subtract 5 on both sides and get 4 for x. All right, let's check to see if 4 works. Let's go back up to the original. If I plug 4 in, 4 minus 3 is 1, square root of 1 is 1, plus 4 plus 5 is 9, square root of 9 is 3. 1 plus 3 equals 4, and it checks. So my answer is x equals 4. That was a pretty lengthy problem. You might want to rewind the video and replay this one more time where you're not actually copying it, you're just watching it so that you can get a better understanding. If you have any questions on anything we did today on this video, please bring them to class tomorrow.